things to remember before we start solving equations and inequalities. So when we're talking about absolute value, that's the distance you are from zero on a number line. So absolute value is always going to end up measuring a positive distance. Distance is always positive. Now, when I am doing absolute value, the distance I am from zero on a number line, you remember I could go to the right or the left. If I had a number line here, I wanted to, I could say, well, 8, I could be 8 away that way, or I could be 8 away that way, right? I could go right or left. So when we're dealing with solving inequalities and equations and absolute value, we've got to account for moving right and left, which means we're going to have two problems to solve. Okay, so first one, first look that I've got here for you says the absolute value of 3x minus 4 is equal to 11. Okay, and we're told to solve that, so this one starts off easy with just an equal sign. You can't be equal to more than one thing. Okay, x can't equal 12 and 13. So that should tell you with the words we talked about yesterday on our and and our or. When it's an equal sign like this, it's going to be an or. We're dealing with an or. So first thing I'm going to do when I have an absolute value problem is write my two problems. You get the first one by dropping your absolute value bars and writing it just like it is. Okay? Or, here's my second problem. I'm going to drop the absolute value bars and make everything on the other side of the equal sign the opposite. So 11 is now negative 11. Okay, now you've got two basic middle school equations to solve. The mistake that most people make when they do this is they forget to write that second equation. Yes?
You read juniors?
1.
You send them down to the multi to get pictures taken?
Sure. Okay, so now to start solving that, solve them each individually. They both got 4 being subtracted, so we're going to add 4 to both sides. So we got 3x is 15, which means x is 5. Okay, or over here, we're going to do the same thing. We're going to add our 4. So it gets me 3x is negative 7. Divide. X is negative 7/3. Okay, so we've always started off this year learning new fancy ways of writing our answers and everything. When we solve this, our answer, it's not going to be, we don't have parentheses and brackets because there wasn't a greater than or less than sign. So this is just going to be a set notation, and I'm going to go from my smallest to largest. So my smallest would be negative 7/3 to 5, and then my set notation is those braces, which I can never draw. The one on the left kind of looks like a man's profile face. So
That's cool.
Got his forehead, his nose, his mouth.
And his chin. It's got fluffy hair maybe.
The one on the right just looks like a squiggly.
What are braces supposed to look
Let me see if I can find one on the keyboard here. I don't even know how to get the keyboard up. Let me show you my book. That'll work. You know, you've seen them a million times. I just can't draw them very good. And that's kind of what you have. Okay, so when it was an equal sign, we had an or. I'm going to make you a note about this, what's fixing to happen. When it was an equal sign, we knew that it had to be either or. Okay, when we see a greater than or a greater than equal to, that's also when we're doing absolute value. That's also going to be an or. This is all when we're doing absolute value. We're in our absolute value notes. When we flip it, see a less than or less than equal to, that's when it's going to be an intersection or an and. Okay, and that's only an absolute value that we're looking at. Alright, so let's work a few of them and look at how to attack them. We're going to take that same base problem that we just did, the absolute value of 3x minus 4. Same start there. But this time it's going to be greater than or equal to 11. Alright. Still got to do the same process even though it's an inequality sign. Anytime we're doing absolute value, we got to have two problems because we got to account for the right side of the number line and the left side of the number line. So I'm going to get my first problem by dropping the bars and just leaving everything like it is. There's my first problem. Alright, now that's a greater than or equal to sign. So is this going to be an and or an or? Or, very good. So I'm going to have or. Now to get my second problem, I drop those bars. When it was an equal sign, we just made everything on the other side the opposite. We're still going to do that. That's still going to be a negative 11. But when it's an inequality sign, we also have to flip the sign. And now, I could tell you this. I might flip the equal sign. Do you know? Doesn't an equal sign look the same way either way it's written? So that's why it's not important to say we're flipping the equal sign because it looks the same way. But inequality sign, you've got to flip it. Okay? So we're going to get you ought to know your answers this is going to produce. We're going to get the same answers on this. Already writing the answer. Plus 4 is what I'm going to do. Plus 4 to 3x is greater than or equal to 15, which means x is greater than or equal to 5. Or, I can fly here because we already did this. Less than or equal to negative 7. Do I flip my sign when I divide by 3? No, because it's a positive 3. Good job, down 10. Alright, so we got the same 5 and negative 7/3. But what's going to be different now is how we write our answer. Anytime you've got an inequality sign greater than less than sign, that's when parentheses and brackets and all that stuff starts coming into play. So I'm going to go ahead and look at what this would look like on a number line, just to get an idea. This is what we looked at yesterday. Negative 7/3 is smaller, it'll be on the left. 5 is larger, it'll be on the right. Okay, greater than or equal to 5. That means it's going to go to the right of 5. And it would get a bracket. Less than or equal to negative 7/3 means it's going to go to the left of negative 7/3. And it would get a bracket. I told you yesterday that most of the time your ors would be shaded in different directions. So you see that here. To write this answer now, this goes to the left forever. That's negative infinity. It goes up to negative 7/3 and touches it, so I put a bracket on it. What's the symbol we looked at yesterday that means or? Not upside down. Regular U, because it's a union. And then we went from 5 with a bracket, we touched it, it got a bracket, to positive infinity. So that would be how we would see that answer written. I was helping a kid on their college algebra this morning, and they weren't doing the same kind of thing, but they were telling domains that went forever, and that's the way the answer was written. It looked like this for their domain. So it is good to know how to write stuff differently. That's the way they're writing it in college algebra. Alright, I'm going to use that same problem again, but just change the sign again. We're covering all of our sign issues here. Everybody got what you need off that page? This one again says absolute value of 3x minus 4. This time it says is less than or equal to 11. So we changed the inequality sign again. So we've done equal to, we've done greater, now we've got a less than. Steps are the same. You've got to get two problems out of that. Get your first problem by dropping the bars, writing everything just like it is. Now before I write the second problem, do I need to put an and or an or? And, very good. Less than goes with and. Now, to write my second problem, I drop those bars. Do I flip that inequality? Yes. Always flip the inequality the second time and make everything over there the opposite. Don't forget to put that inequality sign. Okay? Do you know the answers? This one ought to get you a 5 when you finish it up. So over here, the answers as before. Alright, what's going to make this one different now, since we switched the sign, is just how we're going to write our answer. So let me look at what this would look like on a number line. Number lines help me visualize. Negative 7/3 is smaller, so it'll be on the left. 5 is greater, so it'll be on the right. Okay, I gotta be, this one says I gotta be less than or equal to 5. So less than 5 goes to the left, and it would have a bracket. This one says I gotta be greater than or equal to negative 7/3. Greater than that would go to the right, and it'll have a bracket. So it would be that section that's in between. They're shaded. Remember yesterday I told y'all most of the time ands will be that middle section. So there you see that. Okay, so now to write our answer, ands answers are easier and more simple to write because you just drop this down. That goes from there to there. It's a funny looking 5. You're funny looking. No, you're funny.
At least your fives don't look like noses. Remember last year?
No.
Everyone in front of me because my fives look like noses.
You might want to take it back. They're just so cute.
Well, then, try to blame me for it.
Don't get offensive. If you
No, I'm saying, like, will they blame me for it?
No, tell them it's been like that. There's been several people that got bad ones this year, I believe, haven't they? I know. That's what happens when people use them for a year. Hey, you fixed it. All right, let's add a step. I actually got a new problem this time. Absolute value of 3a plus 2. Then you got a plus 4 is equal to 15. So we're back to an equal sign. So just to tell you what that means to me is I'm still going to have to write 2 problems here in a minute, but I'm not going to have to flip the sign because an equal sign looks the same any way you flip it. But what is different on this one is it's got an extra piece of information. This plus 4 here is extra. When you've got, and I say this real technical, when you've got extra junk, you need to get rid of that first. So I can look at this and say it's got an extra plus 4, so I'm going to move that out. How do I move out a plus 4? Good, so subtract 4 from both sides. Now we've got the absolute value of 3a plus 2 is equal to 11. Okay, so now we're to where we were on the last problems. We got to write 2 problems. Some people will try to write it before they get rid of the 4. You can't do that. You got to get rid of the extra junk first. So we're going to now have 3a plus 2 is equal to 11, or 3a plus 2 is equal to negative 11. So we've got 2 middle school equations to solve there. This side we would subtract 2. 3a is 9, which means a is 3. Same thing over here. Subtract your 2. I wrote 3. 3a is negative 13, which means a, I'm just going to leave that as negative 13 thirds. Okay? Now, this is an or, but it was an equal sign, so it's not a bracket or parentheses question. This, I just write these, make the smallest one on the left, so negative 13 thirds would go on the left, 3 would go on the right, and this would get my braces. Ooh, that one really looks like a face. I'm going to start seeing faces every time I draw those now. It's like making kissy lips, isn't it? Guess I'm the only one that saw that kissy lips there.
Down there on the right hand side?
No. Oh, yeah, kind of. This one. Like the nose is right there, and then the kissy lips, and then the chin. Okay.
Do you just like drawing human figures when you draw these things?
No, I wish I could draw it. Maybe if I could slow down and. That's not fun.
It looks like a fat little bird that doesn't have a neck.
Okay. Alright. This next type is an absolute value of z plus 6 is equal to absolute value of 2z minus 3. So what we've added here now, we've got absolute value bars on both sides. Okay, so we still got to write two equations. This one's got an equal sign, so it's two equations. It's going to be separated by an or. I'm going to get the first equation just like I always have by dropping the bars and writing everything just like it is. Okay, then I've got or. Now when I write my second equation, the left side stays like it is, just like it's always been doing. Z plus 6 is equal to. Now I got to make this whole right side negative. So I'm going to put this step. You don't have to put that step because you know what that means. That's the same as if I distribute, let me bring this one down. If I distribute that negative, that turns that to a negative 2z and a positive 3. So it just made both of the signs the opposite. Okay, everybody see what we did there? We just made everything on the right side the opposite. Okay, so over here, let me solve the left side first on that. What? Say what? Subtract z, Angie said. So that gets me 6 equals z minus 3. So then what does she got to do? Add 3. And z equals 9. 4. Okay, what do you want to do on this side? Add 2z. Gets me 3z plus 6 is equal to 3. Subtract 6. 3z is equal to negative 3. So write my 3 and z is negative 1. So write my answer. This is an equal sign, so I'm in the braces. Negative 1 is smaller, 9 is larger. Key to remember when you have the absolute value bars on both sides is that you made everything on the right side the opposite sign. There's some special scenarios that we can have. So let's look at our special scenarios that can happen. This first one here I've got says absolute value of x is greater than negative 1. Alright, I'm actually not even, I'm gonna show you how you would solve it, but I can do this one using common sense without even solving it. Okay, because absolute value of x always has to be what kind of number? A positive. And isn't every positive number going to be greater than a negative?
Yes.
Yes. So this is kind of one of those no-brainer ones for you there. This is going to go from negative infinity to infinity. Okay? Now, what if I didn't realize that? I had a brain fart, didn't realize it, and I started working it. Okay? That would mean I would drop my bars. X is greater than negative 1. Does greater than get an and or an or? What'd you write down about greater than? And or or? Oh yeah. Look and see. What's your Fontana said it over here a little bit ago. Or. Then I drop my bars, flip my sign, and make it the opposite over there. Okay, so that's already solved now. Well, after I wrote my two problems, there's no solving to do. Let's just look at that on our number line. Negative 1 greater than that would go that way. 1 less than that would go that way. But it's or, so do I have to stop here in the middle? Can't I keep going forever on both sides? Yep. If it were and, it'd have just been that piece in the middle, but it wasn't. So that would be it. There's your negative infinity to infinity. Okay, let's look at another, got two more special kinds of situations. Good. This one says absolute value of t minus 10 minus 2 is less than or equal to negative 3. Alright, we looked at this a second ago. What do we need to do before we can even write our two new problems?
Add 2.
Good, we got to get rid of that minus 2, so we're going to add 2 to both sides. So we've got absolute value of t minus 10 is less than or equal to negative 1. Now, I know this one without doing any work, because I got to have the absolute value of something that is smaller than negative 1. But you just told me that absolute values are always going to be positives. What positive number is smaller than negative 1? What positive, because absolute value is positive, what positive number is smaller than negative 1? There's not one. Devin's right. So I know this is going to be no solution. Okay? But how does that work? Let's look at it and see, in case you didn't realize that. How does that work? I got t minus 10 is less than or equal to negative 1. What, and or with a less than? And. Good. We just did or greater than. Good job. Then I'd have t minus 10, flip it, make that the opposite. Okay, so if I add 10 on this side, gets me t is less than or equal to 9. And if I add 10 over here, gets me t is greater than or equal to 11. So, that kind of looks okay. Why am I saying it's no solution? Well, look at what you got. You're looking for a number that's smaller than 9 and greater than 11. Tell me a number that is smaller than 9, which would be over here, and greater than 11. It's not one. It's not possible. If that had been an or, we'd have been good, but it wasn't an or. It said and. So there's no way that's possible. Alright, the last type of special problem is the easiest, in my opinion. You got what you need there? This one says absolute value of x plus 2 is less than or equal to 0. So they put that 0 over there. Now, if it had just been less than 0, it wouldn't be possible, right? Because you can't have a negative that's less than 0, but we can end up getting equal to 0. So it's still, since it's got the equal bar in there, it's still good. But here's why I think this is an easier one. Drop my bars. Now, what about my other problem? What about my other problem? Still got to write, is it an and or an or? And. Still got to write x plus 2 and flip that, but 0, can I make it the opposite sign? No, it's just 0, right? So, subtract my 2. So, x is less than or equal to negative 2. Subtract my 2. So, x is greater than or equal to negative 2. And this was an and. So, what number do I have that's less than or equal to negative 2 and greater than or equal to negative 2? Just negative 2, right? Because it's got that equal bar. If it had said less than negative 2 and greater than negative 2, it wouldn't be any good. But negative 2 would be it. So my answer for this would just be like the equal problems. It's just going to be in your braces. Just have that one answer. Good job, Bailey. Alright, What we're going to look at doing tomorrow, I'm going to have you an assignment to practice on all this, get you a good grade on it in the grade book, and then Friday we'll do our ACT prep. Then when we come back the next week after that, we'll start doing a couple days of test review and have a test in the middle of the week. Sound like a plan? Easy stuff. Y'all will be all right. That's what we're looking at.